students, in this part we are going to deal with the intensities of the maxima and minima that are being formed due to the interference of the waves. So let's start the part. Hello students, so now we will study about the intensities of the maxima and minima that we have found out earlier. Now what exactly is the intensity? Now when we talk about the intensity is the distribution of an energy. The redistribution of energy. What happens in interference is actually the redistribution of energy. If you see that we had places where we had a maximum intensity and then the places where we had a minimum intensity. Now what are these places of maximum intensity? The places of maximum intensity are the places where the energies are more. The places of minimum intensity or destructive interference that we gave the term are the places where the energy is minimum. What happens is this. Now this is a wave, these are the electrical displacements because we are considering electrical field which is the property of light. So if we consider this has the energy, you have another wave which has the energy. Again this is also electrical displacement. What happens? Now this is the energy. When this meets with this energy, what will happen? There is no loss of energy here, there is no dissipative loss of energy. So what happens is that there is a total energy. Suppose you have an energy value given by E naught. This is energy I am writing, this is also E naught. This is the total energy that this carries and this is the total energy that this portion of the wave carries. Now when they will interfere, what happens is that at some point you have constructive interference, that is maxima will happen. Maximum value is the maxima and it happens where constructive interference happens. And then you have minima. Minima are the places where destructive interference happens. Okay, and we have seen, if you remember, the constructive interference was happening when the phase difference phi was equal to 2n pi. Right, because cos phi becomes plus 1 here and the maximum value used to happen and it happened at 2n plus 1 pi where n is an integer and phi is the phase difference between the two waves. This is a one wave, this is the two wave, second wave. Now these two have a phase difference of phi. When this holds true we have a maxima, when this holds true we have a minima. Now between these two maxima and minima there is a gradual value of maxima. Means suppose the maximum value of intensity is I naught, minima is 0. So what will happen? The intensity, this is the maxima, this is the minima. So it will go from I naught to 0. It's not that you only have a I naught value and you have a 0 value. You have a gradual change from I naught to 0 and then again it will go from 0 to I naught. How? Suppose the phase difference is 0. What will happen? Maxima will happen. This is maxima, the intensity is I naught. Then the value will change. Suppose it is pi by 2, right? Now this is intermediate value. This is any intermediate value. Intensity is something I, it is less than I naught. Then you go to pi. Now as soon as you reach pi, the phase difference becomes pi between these two. We are seeing what is happening. As soon as the phase difference becomes pi, this satisfies this condition because n is equal to 0 will give you pi, right? So there will be a minima. So when this happens, you will have a minima, intensity is 0. So from I naught it decreased to 0. So in between 0 to pi by 2 there are all the values, the infinite number of values. So you will have an infinite number of values for maximum. Again you go from pi to 3 pi by 2. Again you will have some value similar to like this. Then you reach 2 pi. Once you reach again 2 pi, as I told you, a phase difference of 0 is equal to a phase difference of 2 pi. There is no difference between a phase difference of 0 and a phase difference of 2 pi for sine and cosine waves, right? Because they repeat after 2 pi. They are exactly identical after 2 pi. So there is no way identifying which is 0 or which is 2 pi. So again as it reaches 2 pi, you can also see from the formula when n is equal to 1, n equal to 0 you had 0, n equal to 1 it's 2 pi, n equal to 2 it will be 4 pi. So that's how when maxima happens. So 2 pi will give you I naught. Again it will go as you reach 3 pi, it satisfies this condition, you will have 0. So this is how the maximas and minimas are changing. So now this is what mathematically is happening. What will happen when you observe this on a screen? that is screen. Suppose I make this is a screen. Okay. Now what I do is, suppose you have, this is a maxima. Suppose this is a maxima, means this is the point, like you had two waves coming here and here, they are meeting, and then you are getting a pattern here. This pattern, these two are meeting, this plus this, you are getting a pattern. You will observe this pattern, right, where you are observing. So you may take a cardboard, you may take any other screen, and there you are observing like what kind of this distribution is happening, what this maxima actually is. You will find that this is a bright white line, very bright white line. Exactly, means if you have these two as the white light sources, then you will have a bright white light. After this you will find there is a region of minima. The minima will happen when the phase difference will be equal. In this position you will have a region like this. This is totally dark, you will not find any light here. Similarly again here there is no light, and again after this, again what will happen? Again you will have a maxima. So this is white, although I am using a different color, this is actually white, this is again white. Okay, so what you see here is that now this happens according to this. Okay, and obviously there is a gradual change, like I showed you, it goes from 0 to pi by 2 to pi, gradually it's changing. So it's not like there is a bright maxima line and then again there is a dark line. There is a gradual change from there to there, but you can identify that okay, this is the maximum intensity, very bright line, and then there is a very dark line, and then there are phase changes. Okay, so this is the maxima, this is the minima, this is the maxima, again this is a minima. This is the pattern that you will observe on a screen. So what is happening is that this was the total energy. If you remember, I started with this, that there was an energy that was present in both of the waves, right? So now this energy, this was E naught and this also, I am assuming both are the same energy. What will happen? This total energy will redistribute, right? So wherever there is a brightness, that means the energy is concentrated there. Wherever there is black region, means there is no light, the energy is zero there. What is happening is that this total energy 2 E naught is distributed in this region, and this region. This total energy, it gets distributed in these three regions, and then you don't have these regions. Obviously I am not telling here that there won't be any fringes here to here. Obviously if there will be fringes there, which will happen, then you will have energy distributed there also. Okay, but this is what happens if we assume that there are three fringes being formed and then there are two black fringes. This is what is happening. And now the most important part, the most interesting part of this was that the presence of those black fringes. Now till then, in the history of the development of interference, the people thought that when you have a light source, you will always have a brightness. It will always be bright. If you have two light sources, it will be more brighter, right? It's not possible that you have two light sources and then you have a dark pattern there. And this is what happens in interference, that although these are the two light sources, at this point you had a maxima, at a point you had a minima, means there was no light. So it was totally astonishing for the physicists and scientists at that time. But how is it possible that two light are coming, two white lights are coming, and then there is no light there? So at that point actually this reason was not there. They didn't know of this, that there is a phase, there is a wave-like character. So at some point the phase becomes out of phase, so it will interfere. Net effect becomes zero. Net effect zero, which practically physically means that there is no light. So all these kinds of concepts were not there. So this was very astonishing in that sense, and it is even today. Like if you ask someone, a lay person, like what will happen if you put two light sources, it's very difficult to comprehend that there will be a darkness, there will be no light intensity, and this is what exactly happens. And why it is happening? It's happening because of the interference pattern. So now we'll try to quantify this energy. Now energy is quantified in terms of intensities. Now the intensities that we have here, if you see, we had seen earlier that intensity is proportional to the square of the amplitude. So if I write this equation for the first is, suppose E naught cos omega t plus y. Okay, a wave, cos wave, a sinusoidal curve. This is a sinusoidal curve. suppose E2, you have anything, E naught dash, some different amplitude, cos omega t plus suppose alpha, some different phase. Okay, so now these are the two waves that we have. Now intensity is proportional to the square of the amplitude, means if its amplitude is E naught, the intensity will be proportional to E naught square. It's proportional. I'm not telling it's equal, it's proportional. Means if this value is 2 E naught, the intensity will be 4 E naught square. Okay, so now since the intensity is proportional to the amplitude square, we write it like this: intensity is proportional to the amplitude square. So intensity is constant of proportionality into A square. We remove this proportionality by a constant of proportionality. Okay, and so this becomes K square. Now, so what will be the maximum intensity? It will be proportional to A plus B whole square. Why? Because we saw that the amplitude was actually this. Okay, this was the amplitude. So maximum intensity will happen when this will be plus 1 and it will become A plus B. So this will become A plus B when cos phi is plus 1. So if this is amplitude, intensity will be proportional to the square of this. Similarly, what will be the minima? It will be A minus B whole square. Right? So if you remove this constant of proportionality, you will have a K. So even if you put K, you will have a thing like this. Right? So when we are dividing these two, this will cancel out. You have this value. Okay? Now what we do is that from here we take A outside. Sorry, we take B outside. So if you take B outside, you will have B square here, A by B plus 1 whole square, and then you will have same thing here. Now this 2 cancels out. Okay, so you have this. Now this A by B is called the ratio of amplitude. Means if it is E naught and this is E naught dash, so E naught by E naught dash, this is the ratio R, and this is what A by B, what we have assumed here. So this is the ratio of the intensities. Means this is a maxima intensity and this is minima intensity. Now can you tell me what will be the maximum intensity when both have the same amplitude? If I make the amplitude same, what will be the intensity? Maxima intensity, and what will be the minima intensity? We'll see this. So the relation between the amplitude intensity of the wave and the width of the slit. Now this is a new thing that we'll see how exactly it depends. But we have seen that intensity is proportional to square of amplitude. So I1 by I2 is A1 square by A2 square. So my question was, what will happen when both are of the same value? Now what will happen both are of the same value? What will happen to I minimum? This B becomes A. So A minus A is 0. So that means in that case, the minimum intensity is 0. Otherwise, suppose if they are not equal, what happens? Suppose B is greater. So B is greater means this value is negative, but intensity is a square of this. So again, this is a positive value. So this will always be positive. If they are not equal, they will always be positive. Positive means it will never be complete darkness here. This is what the physical significance of this is. Means you will never have a complete darkness if they are not equal. But if they are equal in amplitude, you will have a complete darkness and then you will have a bright fringe. Bright fringe, then again darkness, again bright. But if they are not equal, there will be a bright and then it will diminish, but it will not be totally dark. You can see it from here. Minimum is not dark. So it will come down in intensity, again it will rise in intensity, again it will go down in intensity, but it's never dark. Okay, so now this is this. Now there is a relation that the intensity, the amplitude is proportional to root W. Now this is a practical observation that suppose if we have a slit like this, means a wavefront is coming, you block this by a cardboard which has a small hole of width, suppose W. So when it is reaching here, the amplitude that is coming out is proportional to root of width. So that means, so when you put this A1 square by A2 square, what you will have is this root over W1 square by root over W2 square, which is W1 by W2. Okay, So this is what the relation is, intensity, and we have seen what this physically means, what kind of appearance we'll have, is what is the thing that we observe. So, and these are the values that how we calculate, how this is proportional, how we get this ratio, what will happen when they are equal, what happens when they are not equal. There is no normal misconception that when the difference is larger, you may have a darkness and then a very large value. No, there will be complete darkness only when both are equal in magnitude. Okay, and this is very evident from here. Okay, so let's see a question. It's a continuation from the last part. If you see the two coherent sources, they emit light waves which superimpose at a point where these can be expressed this and this. Even in E2 are the electric field strengths. Find the resultant intensity if the intensity due to E1 is I. This is given to you and you have to find out this. Now, what is the resultant amplitude? See, we know that intensity is proportional to the square of amplitude. That means we can write intensity is constant K times A square. This is the relation that you have. Okay, and this is the single relation that we'll be using to solve this question. Now, first thing, E1 is this, E2 is this. Okay, so now you know that the net amplitude square is A square plus B square plus 2AB cos phi, where phi is the phase difference. Now, there are two ways of writing this. Now you can write this amplitude A square. We can write this A square in terms of intensity, right? So I can write A square as I by K. That means I is the net intensity. If you remember, this was net amplitude. So I net by K. This will be, what will be this? This will be intensity of the first one by K. Again this will be same, right? When this is I1, this will have a small a square, you will have I1. When you have B square, you will have I2. That is the intensity of second one. So similarly, we will write this. Plus twice AB cos phi. What will be A? A will be root over I1 by root over K, root over I2 by root over K into cos phi, right? So from this simple relation, we can get actually a relation between intensities. Okay, so what is that relation? That relation is I net is equal to, this K will cancel out from everywhere, right? Root K into root K will give you K. This is I1 plus I2 plus 2 times root over I1 I2 cos phi, right? Now what is I1? Can you find out I1 from here? Definitely. I1 is K times E0 square, right? What is I2? I2 is K times 2 E0 square. You have to square the magnitude. So this is actually 4K E0 square, right? Now see one thing. What is given to you is that intensity due to E1 is I, means this value is actually equal to I. This is given to you in the question. Now if this is I, what is the value of this? This will be 4I, right? So what will be I net? I1 is I, I2 is 4I plus 2 times root over I into 4I into cos phi. What is phi? Phi is the phase difference between these two waves, right? So how to find out the phase difference? This is phi 1, this whole thing is the phase, this whole thing is the phase, this is phi 2. Phase difference delta phi or phi, this is equal to phi 2 minus phi 1, or you can find out phi 1 minus phi 2. So what is the phase difference? Omega t plus pi by 4 minus omega t minus pi by 4. What is the value that you get? You will get pi by 2, right? This is phi. Phi is pi by 2. What will be cos phi? 0. Cos pi by 2 is 0. So this is 0. So what you get is 5 times I. So the net intensity is 5 times the intensity of first one. See, so the only relation that we had to use was this, and then you have to apply this formula. We can convert from amplitude to intensity in this manner. We use this formula again here. So you got a relation in the terms of intensity. This, you can remember this formula. You can straight away put it, or you have this formula. From here you can always put it and get this formula. So this is how we put the values of phi. We use, so only formula is being used here is this, and we use the phase differences, and so we got the answer. I hope you have understood this portion. So we have studied how the intensity distribution happens when the interference of the waves occur. So in the next part, now we are going to deal with these properties used in Young's double slit experiment. So stay tuned to Ask IITians for more on this.